Hello, my dear students. Welcome to IK Sir Chemistry classes. Here we are in lecture number 4 on solid state for chemistry students of class 12. This video will also be useful to JEE and NEET aspirants. In this video, we will discuss the various types of unit cells on the basis of position of particles. First of all, we will discuss simple unit cell, which is also called primitive unit cell, and it is denoted by P. The unit cell in which the particles are present only at the vertices is called a simple unit cell or primitive unit cell, which is denoted by P. It is obvious that in the simple unit cell, the particles are present only at the vertices and not elsewhere. This is the diagram for a simple unit cell. This particle occupies the vertex of the unit cell. It may be noted that all the vertices of this unit cell are occupied by particles, and particles are not present at any other position. All the particles are present at the vertices, and hence it is a simple unit cell or primitive unit cell in which particles are present only at the vertices. The next type of unit cell is centered unit cell. The unit cell in which the particles are also present on the centers of faces or at the body center in addition to the vertices is called centered unit cell. Let us repeat it again. The unit cell in which all the vertices are occupied by particles, and at the same time some particles are also present at centers of faces or at the body center, and this type of unit cell is called centered unit cell. The centered unit cell is of three types: body centered unit cell, which is denoted by I; face centered unit cell, which is denoted by F; and finally end face centered unit cell, which is denoted by C. We will discuss all these three types of centered unit cells separately in detail. First of all, we will see body centered unit cell, and it is denoted by I. In the body centered unit cell, the particles are present at all the vertices and the body center of the unit cell. It is obvious that the unit cell in which the particles are present at all the vertices as well as body center of the unit cell is called a body centered unit cell. It has been represented diagrammatically here. This particle occupies the vertex of the unit cell. In fact, all the vertices of the unit cell are occupied by particles. At the same time, the body center of the unit cell is also occupied by particle. This particle occupies the body center of the unit cell. It is obvious that the particles are present at all the vertices of unit cell as well as at the body center of unit cell, and hence it is body centered unit cell. And next type of centered unit cell is face centered unit cell, which is denoted by F. If the particles are present at all the vertices and centers of all the faces of the unit cell, it is called face centered unit cell and it is denoted by F. It is obvious that in the face centered unit cell, all the vertices and centers of all the faces are occupied by particles, and it has been represented diagrammatically as follows. This particle occupies the vertex of the unit cell. In fact, all the 8 vertices of this unit cell are occupied by particles, and this particle occupies the face center of the unit cell. This is the face of unit cell whose center is occupied by particle. In fact, all the face centers of the unit cell are occupied by particles. And next type of centered unit cell is nothing but end face centered unit cell, which is denoted by C. If the particles are present at all the vertices and the centers of any two opposite or parallel faces of the unit cell, it is called end face centered unit cell. It is clear that in the end face centered unit cell, particles are present at all the vertices. At the same time, the particles are also present at the centers of two opposite or parallel faces as demonstrated diagrammatically here. This particle occupies the vertex of the unit cell. In fact, all the vertices of the unit cell are occupied by particle. 4 vertices on the top face and 4 vertices on the bottom face. At the same time, this particle occupies the face center of the unit cell. The center of this face is here and it is occupied by particle. At the same time, its opposite face, that is parallel face, also contains a particle at the center. In this unit cell, all the 8 vertices are occupied by particles and centers of 2 opposite or parallel faces are also occupied by particle. Cubic unit cell. The unit cell having the following characteristic unit cell parameters. A is equal to B is equal to C. That is, edge length along x-axis is equal to edge length along y-axis, and it is again equal to edge length along z-axis. That is, A equals to B equals to C. The edge length along all the 3 axes are equal, and alpha is equal to beta is equal to gamma, and all these are equal to 90 degree. It means the unit cell in which edge length along the axis are equal and the interaxial angles are also equal to 90 degree is called a cubic unit cell. Here alpha, the angle between y and z axis, is equal to angle between z and x axis, that is beta, and it is equal to angle between x and y axis, that is gamma, and all these 3 angles are equal to 90 degree, and such unit cell having these characteristic unit cell parameters is called cubic unit cell. Features of a cubic unit cell. This is a cubic unit cell and it is the edge of cubic unit cell, and it is the edge center of the edge. This is the face of unit cell and it is face center of this face. This position is called vertex. The point at which more than two edges or sides meet together is called vertex, and it is the body center of the cubic unit cell. Let us count various components of the cubic unit cell. The cubic unit cell has 12 edges. How we can count these 12 edges? 1 edge, 2 edges, 3 and 4 edges are present on the top face. 4 edges are present in the bottom face. 4 plus 4, 8, and there are 4 edges in vertical position, 1, 2, 3 and 4, and hence there are 12 edges in the cubic unit cell. There are 6 faces, 1 face on the top side and 1 face on the bottom side, 2, and 4 faces are in the vertical position, 1 face, and there are such 4 faces which are in vertical position. 8 vertices. The cubic unit cell has 8 vertices, 1, 2, 3, 4 on the top face and 1, 2, 3 and 4 on the bottom face, and only one body center. It is clear that cubic unit cell contains 12 edges, 6 faces, 8 vertices and 1 body center. All these must be remembered for further discussions and to understand further concepts easily. Types of cubic unit cell. Cubic unit cell is of 3 types. In this cubic unit cell, particles are present only at the vertices and hence it is simple cubic unit cell and represented by P. In this cubic unit cell, particles occupy all the vertices at the same time. The body center of the unit cell is also occupied by particle and hence it is body centered cubic unit cell, denoted by I and abbreviated as BCC, body centered cubic. And in this cubic unit cell, particles are present at all the vertices and all the face centers of the cubic unit cell are also occupied by particles. This top face is occupied by particle and this bottom face is also occupied by particle at the center, and 4 vertical faces also have a particle at their center and hence it is a face centered cubic FCC unit cell and it is denoted by F. There are 3 types of cubic unit cell: simple cubic unit cell, body centered cubic unit cell and face centered cubic unit cell. Hexagonal unit cell. The unit cell having the following characteristic unit cell parameters: A is equal to B but not equal to C. Alpha is equal to beta is equal to 90 degree but gamma is equal to 120 degree. is called hexagonal unit cell. It is obvious that in hexagonal unit cell, A is equal to B but not equal to C, and alpha is equal to beta is equal to 90 degree and gamma is equal to 120 degree, and such unit cell is called hexagonal unit cell. It has been represented diagrammatically here. This is x-axis, y-axis and z-axis. The edge length along x-axis, that is A, is equal to edge length along y-axis, that is B. But the edge length along z-axis is not equal to A and B. This one. This is xy plane and z-axis is perpendicular to it, and therefore the angle between y and z-axis, that is alpha, will be equal to 90 degree, and the angle between x and z-axis, that is beta, will also be equal to 90 degree. Thus alpha is equal to beta is equal to 90 degree, and gamma, that is the angle between x and y axis, will be equal to 120 degree. It is a regular hexagon whose all the internal angles are equal to 120 degree. Thus, the unit cell having these characteristic unit cell parameters is called hexagonal unit cell. Type of hexagonal unit cell. The hexagonal unit cell is of only one type, which is called hexagonal closed packed HCP unit cell. It has been represented diagrammatically here. This particle occupies the vertex of HCP unit cell, and this particle is present at the center of hexagonal face. This particle is present at the center of hexagonal face, and the center of other hexagonal face is also occupied by particle, and these three particles are present within the body of the unit cell. This is HCP unit cell, and it has 18 edges. How we can calculate these 18 edges? 1, 2, 3, 4, 5 and 6 edges are present on the top face. 6 edges are present on the bottom face. There are overall 12 edges and 6 edges in the vertical position. 1, 2, 3, 4, 5 and 6, and therefore HCP unit cell contains overall 18 edges. It contains 2 hexagonal faces, one hexagonal face on the top side and one hexagonal face on the bottom side. 6 rectangular faces. This is rectangular face. This is rectangular face and it is present in vertical position, and there are 6 such rectangular faces. There are overall 12 vertices. 6 vertex on the top face and 6 vertex, 1, 2, 3, 4, 5 and 6 on the bottom face. There are overall 12 vertices. It is obvious that a HCP unit cell contains 18 edges, 2 hexagonal faces, 6 rectangular faces and 12 vertices. Thank you for watching the video with patience. If this video is useful and beneficial to you, please like it so that inspired from it I may bring more useful videos before you in future. Please share it for the benefit of your friends, and if you have not subscribed my channel yet, please subscribe it so that you may get information regarding my new videos in time. Thank you again.